In this episode, we are moving into a part of Windows security that can feel confusing at first because several different ideas all seem to overlap, even though each one answers a different question. A domain helps decide how systems and users are managed together. Policies help enforce rules consistently. BitLocker protects whole drives. Encrypting file system, EFS, protects individual files and folders, and user rights determine what people are actually allowed to do on a system. For a beginner, it is easy to hear all of that as one giant security topic and miss the reason each part exists. The easier way to understand it is to think of them as layers of control around identity, behavior, and data. One layer helps centralize administration, another helps standardize settings, another helps protect stored information, and another decides what actions a user account can perform. When technicians understand how those pieces connect, they make better support decisions because they stop treating access problems, encryption choices, and policy restrictions as random Windows behavior and start seeing them as deliberate parts of a security model. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at CyberAuthor.me in the Bare Metal Study Guide series. A domain is important because it allows many computers and users to be managed as part of the same organized environment instead of as a collection of unrelated machines. On a standalone system, settings and accounts are mostly handled locally, which may be manageable for one home computer or a very small setup, but it becomes harder to control when an organization has many users, many endpoints, and many security expectations that need to be applied consistently. In a domain-based environment, users can sign in with centrally managed credentials, administrators can apply rules across multiple systems, and access decisions become more predictable. That does not mean domains magically make a system secure. What they do is create structure, and structure is what makes security easier to enforce at scale. If every machine is managed differently, every account is local, and every setting depends on the last person who touched it, then security turns into guesswork. A domain reduces that chaos by giving the organization a way to manage trust, identity, and system behavior as part of one coordinated environment rather than many separate ones. This matters for technicians because support work changes depending on whether a machine is part of a domain or operating more independently. A user who cannot access a shared resource, cannot apply a setting, or suddenly loses some capability may not be dealing with a local problem at all. The cause may come from a domain-level decision, which means the system is behaving the way it was instructed to behave by central management. That is why beginner technicians need to stop assuming every Windows issue begins and ends at the device in front of them. In a domain environment, access and configuration often have a larger context. The computer is not just a private island. It is a member of a managed group, and membership comes with rules. Once you understand that, many strange-looking support cases make more sense. A restriction may not be accidental, a disabled feature may not be broken, and a missing option may not be the result of corruption. Sometimes the system is simply following domain instructions that were designed to keep the environment consistent and secure. Policy-driven control is the next piece because once systems belong to a managed environment, the organization needs a reliable way to push out rules. Policies are those rules. They define how systems should behave in areas such as password requirements, lock screen timing, software permissions, security baselines, network behavior, and many other settings that matter to day-to-day protection. The real value of policies is consistency. Without them, every device may end up with slightly different settings depending on who configured it, when it was configured, or what exceptions someone made in a rush. Those differences create confusion for users, extra work for support teams, and gaps that attackers may exploit more easily. Policies reduce that drift by making system behavior more uniform. From a security point of view, that is powerful because the organization is no longer hoping every endpoint will be configured correctly by hand. It is defining expectations centrally and having the systems follow those expectations automatically, which makes protection more stable and easier to audit over time. One of the best ways to understand policy is to think of it as a quiet form of organizational discipline. Users often do not notice it until it affects something they want to change, such as when they cannot alter a security setting, install certain software, or keep a session unlocked longer than allowed. To the user, that can feel like an annoyance, but from the technician's point of view, it is often a sign that the environment is being managed intentionally rather than casually. Good policy is not there to make people miserable. It exists because computers are used by many different people under many different conditions, and not all of them will make safe choices every time. Policy helps remove some of the guesswork and prevents avoidable mistakes from becoming larger problems. It also helps new technicians recognize that a system may be restricted for a good reason. Before changing settings to make a complaint disappear, they need to ask whether the restriction reflects a policy decision meant to protect the device, the data, or the broader environment. This leads naturally to the idea of user rights, because policies can set broad expectations, but user rights determine what specific actions an account is allowed to perform. User rights are about practical authority on a system. They shape whether a user can install software, shut down a server, back up files, log on in certain ways, change time settings, manage other accounts, or carry out sensitive actions that ordinary users should not perform freely. Many beginners confuse user rights with simple file access, but they are not exactly the same thing. File and folder permissions determine what someone can do with particular content, while user rights speak more to system-level abilities and sensitive operating functions. This distinction matters because a user may be able to open a document but still have no authority to perform administrative actions on the machine. In security terms, user rights are one of the clearest examples of how Windows translates organizational trust into technical reality. What a person can actually do depends not on what they want, but on what the system has been told to allow. That is why user rights have such a direct effect on real support outcomes. A user may sign in successfully and still be blocked from carrying out a task they assume should be normal, such as installing an application, changing a service, modifying a protected setting, or using a function that requires greater privilege. To the user, the system may seem broken or unfair. To the technician, the real question is whether the user lacks a necessary right, or whether the right is correctly withheld because the task exceeds what the role should allow. This is where confusion causes trouble. If a technician solves every complaint by increasing privileges, security gradually weakens because more and more users accumulate powers they do not genuinely need. Over time, that makes mistakes more dangerous, malware more effective, and account compromise far more damaging. Understanding user rights means understanding that access should be tied to responsibility and purpose. The system stays safer when users receive the minimum authority needed for their actual work rather than broad power granted for convenience. Now it helps to turn to BitLocker, because while domains, policies, and user rights focus heavily on identity, behavior, and control, BitLocker focuses on protecting data stored on a drive. Its job is to help ensure that if the device or drive falls into the wrong hands, the information on it cannot be easily read. This matters most in situations involving loss, theft, disposal, or unauthorized physical access. A laptop can have strong policies, careful user rights, and a well-managed domain relationship. But if someone steals the device and can simply remove the drive and read its contents, then all those controls no longer help in the same way. BitLocker addresses that gap by protecting the data at rest, meaning the information remains protected when the machine is powered off or the storage is accessed outside normal authorization. For technicians, the biggest lesson is that BitLocker is not primarily about stopping a user from opening their own files during normal work. It is about changing the outcome when physical control of the device is lost. BitLocker makes the most sense when the organization wants broad protection for a whole system drive or another complete volume, especially on portable devices like laptops where loss and theft are realistic concerns. It is also useful when a device contains sensitive business information, cached credentials, email content, documents, or other data that would cause trouble if exposed through physical compromise. In other words, BitLocker is a strong fit when the question is how to protect the entire storage environment instead of a small set of selected files. That is why it is often associated with full disk protection rather than user-by-user file secrecy. A beginner should understand that BitLocker is a device-centered encryption choice. It protects at the drive level and is especially valuable when the system itself may leave secure spaces. If a desktop never moves and holds little sensitive data, the urgency may feel lower, though risk is never truly zero. On mobile systems, though, BitLocker often makes clear practical sense because mobility increases exposure. EFS works differently, and this is where many students get turned around because both BitLocker and EFS involve encryption, yet they do not solve the same problem in the same way. EFS is used to encrypt individual files or folders rather than an entire drive, which means it is more selective and more closely tied to user-level access. That makes it useful when the goal is to protect specific content rather than the full storage device. In plain terms, BitLocker says protect the whole drive from unauthorized offline access, while EFS says protect these particular files or folders in a way that depends more directly on authorized use. EFS can make sense when certain information on a shared or multi-user system needs extra privacy beyond general permissions, or when only a subset of content requires stronger protection. However, it also introduces more complexity, because selective encryption at the file level brings questions about who owns the files, who can recover them, and how access behaves when accounts change or data is moved. Because of that, technicians should not think of EFS as a better version of BitLocker or as a default replacement. EFS makes the most sense when the need is targeted protection of certain files and when the environment is prepared to manage that complexity carefully. BitLocker is usually easier to understand as whole device protection against physical loss or theft, while EFS is more nuanced because it focuses on specific content and can be affected by user context and account-related conditions. If the main concern is a stolen laptop, BitLocker is usually the clearer answer because it protects the broader device. If the concern is a particular set of files on a system where selective protection is needed, EFS may be appropriate. The mistake is assuming that all encryption tools are interchangeable. They are not. They are shaped by different goals. Good technicians choose between them based on what needs protection, how users work, and what kind of risk is actually being addressed rather than simply enabling encryption somewhere and assuming the job is done. A useful way to compare these ideas is to ask what question each one is answering. A domain answers how users and systems are centrally managed together. Policies answer how rules are applied consistently across that environment. User rights answer what actions an account is truly allowed to perform. BitLocker answers how to protect an entire drive if the device itself is lost or accessed outside normal control. EFS answers how to encrypt selected files or folders when more targeted protection is needed. Once you frame the topic that way, the confusion starts to clear because you can see that each concept belongs to a different part of the security picture. The beginner mistake is trying to collapse them into one general notion of Windows security. In reality, they are connected but distinct. One is about centralized management, one is about standard behavior, one is about account authority, and two are about protecting stored data in different ways. Security becomes easier to understand when you stop asking which tool is the one solution and start asking which problem each tool is meant to solve. These controls also reinforce one another in practical ways. A domain provides the structure for centralized management. Policies make sure systems follow the organization's expectations rather than drifting into unsafe inconsistency. User rights keep accounts from having more system authority than they need. BitLocker helps ensure that a stolen laptop does not become an open book full of readable data. EFS can add more focused protection where certain files deserve special handling. Together, these measures create a more disciplined environment in which identity, behavior, and information are all managed with greater care. None of them eliminates every risk. A domain can still be mismanaged, policies can be poorly designed, user rights can be granted too broadly, and encryption can be deployed without clear planning. But when these controls are understood and used for their proper purpose, they reduce common weaknesses that show up again and again in Windows environments. That is why technicians need conceptual clarity. They do not have to design every policy from scratch, but they do need to recognize what each control is trying to achieve. Support work becomes much better when technicians can read symptoms through this lens. A user who cannot install software may be limited by user rights rather than facing a broken installer. A machine that keeps reverting to certain settings may be following a policy rather than malfunctioning. A lost laptop may still represent a serious event, but the impact changes significantly if BitLocker protected the drive. A user trying to access specific encrypted content may run into EFS-related complications that have nothing to do with simple file corruption. These distinctions matter because the wrong diagnosis leads to the wrong fix. If a technician assumes every restriction is a problem to be removed, security erodes. If the technician assumes every problem is a security control working correctly, real faults may be missed. The better path is understanding the purpose of the control and then deciding whether the current behavior matches that purpose. That kind of judgment is what separates rote troubleshooting from thoughtful support in a managed Windows environment. As we close, the main idea to carry forward is that domains, policies, BitLocker, EFS, and user rights are easier to understand when you stop viewing them as one tangled topic and instead see them as answers to different security needs. Domains bring centralized management to users and systems. Policies apply consistent rules across that managed environment. User rights define what accounts are actually allowed to do at the system level. BitLocker protects whole drives when physical access to the device becomes the risk, and EFS protects selected files or folders when more targeted encryption is needed. For a beginner, that clarity is powerful because it turns a confusing set of Windows terms into a practical framework for thinking about support and security. When you know what each control is for, you are far less likely to make careless changes, far more likely to interpret restrictions correctly, and much better prepared to support users without weakening the protections that keep the environment stable and safe.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.